Okay, today we're going to be talking about properties. This is not the most exciting thing in the world. Hopefully you've seen them before. If not, we'll go over this. I also know they're all written in terms of variables. That's why in the questions I'm going to ask you to define them in terms of numbers. So the first one we're going to start off with is the closure property. The closure property is pretty easy. It says for all real numbers, which from now on I will abbreviate as this, the double R, that's all real numbers. So for all real numbers, A and B, A plus B is a unique number. And A times B is a unique number. That means if I'm, add 1 plus 3, I'm always going to get 4. It's unique. I'm never going to get something else. So go ahead and define A times B with real numbers and tell me what unique answer you get. The next property is the commutative property. Again, this is one you've probably seen a million times since second grade. And we have a commutative property of addition and multiplication. So, for all real numbers, A and B, we know that A plus B is equal to B plus A, and we know that A times B is equal to B times A. It does not work for subtraction and division for obvious reasons. Those are getting smaller, and I have to have a number that I'm taking away from or dividing from, and one that I'm using to divide or take away. Okay? So it works for addition and multiplication. Go ahead and give me an example of each. The next property is the associative. Again, one you've probably seen before. This says, for all real numbers, A, B, and C, we're adding that C in there, that I can do this. A plus B plus C equal to A plus B plus C. I can essentially group whatever numbers I want together if it's easier for me to do those first or other ones later. I can also do it with multiplication. A times B times C is the same thing as A times B, C. Okay? Again, this only works with addition and multiplication. Go ahead and give me examples of both. Now we're going to be talking about properties of quality. And there are 3 different properties of equality. Equality meaning equal. So, I'm only going to define it once. For all real numbers, A, B, and C, I have 1, the reflexive property. Which literally just says that A is equal to A. Any number is equal to itself. It doesn't seem super important, but trust me, it is. You kind of saw that on some of those word problems when I had 2 things written in the same column. I set them equal to each other because the larger number is always equal to the larger number. It's equal to itself. And so it didn't matter that I had 2 different things. I could set them equal to each other. The second property that is of equality is the symmetric property, which says that if A is equal to B, I can flip that around and B is equal to A. Again, seems rather intuitive, but can be very important in algebra. Okay? The third thing, transitive. which says that if A is equal to B and B is equal to C, guess what? A is also equal to. That's right, it's also equal to C. And if you kind of join these two together, you will see that A is equal to B, B is equal to B, B is equal to C, and since B is equal to B, I can just kind of get all those out and say that A is equal to C, okay? So I'm going to let you give me examples of all three of those in real number kind of things. We're down to two more properties. The identity property. Identity is easy, and you've seen it before. If A is added to 0, my result will always be A, or that number. That's the identity property of addition. The identity property of multiplication, what do I need to multiply by to get A itself? A, or times 1, sorry. 1 times A will always give me A, or whatever that number is. Give me examples of both of those using real numbers. Last property, I promise, and you'll remember this one from years past and how important it is all the time, and that's the distributive. Probably one of my favorites. Just to show you how important it is. 3 exclamation marks. And that says if I have A times some B plus C. Stop. No. There we go. A times some B plus C. I can distribute that A across to everything so that I get A times B plus A times C. Make sense? It also works if what I have in the parentheses is being subtracted, like A times B minus C. Again, I can distribute all the way through so that I get AB minus AC. The symbol inside the parentheses stays when I distribute. Give me an example of that using real numbers, and then you are done.